Hi everybody, it's Michael again. He is doing his fourth surface type on potential and kinetic energy. Again, we have our wall marked every 20 centimeters, 20, 40, 60, 80, and 100. So from 20 up to 100 centimeters. And we're going to bounce the ball on the surface type, letting it go one time on 3 takes and letting it bounce 3 times per take. So this surface type is going to be carpet. We just used our living room wall, hallway living room wall for our experiment and the carpeted floor. So we're going to go ahead and start. Michael's going to stand sideways, putting his feet perfectly together, body perfectly straight so that there's no change in variables, and holding the ball up to his brow bone. This is at 5 feet. Michael again is 5'3", so if he holds it up to his brow bone and not above his head, we should be right in there. So we're going to go ahead and drop the ball for the first take and let it bounce 3 times and see where it jumps up to each time. Okay, Michael, you can go ahead and drop the ball. Okay, it looks like I saw 40, 25, 20, but we're going to try it again for take 2, and we're going to do the exact same thing, checking to see where it falls. Okay, go ahead. I saw about the same thing, about 60, 25, 20. So we're going to try this again, changing no variables, back perfectly straight, and ball held at the same height, feet perfectly together. Okay, we're going to drop the ball for the last take. Drop the ball. Yep, I saw the same thing all 3 times. 60, 25, 20 on a carpeted surface. Thank you, Michael. That concludes our final surface type to show potential kinetic energy once it hits an elastic collision, how much friction that costs and takes away from the kinetic energy of the ball. So it would appear that kinetic energy is lost after an inelastic collision, and depending on the surface type that it hits, that is how much kinetic energy is reserved or not reserved back into the ball, allowing it to bounce up, higher, or lower. This would mean it takes more energy to dribble a ball on softer surfaces than harder surfaces, as harder surfaces, per our experiment, return back more kinetic energy than softer surfaces do. Softer surfaces absorb the kinetic energy on the inelastic collision, creating it a harder time to dribble the ball. All right, that concludes our experiment. Bye everybody, this was fun.